record. All right. And I think this is where we usually get a little bit ahead. So I think at this point, I turn it over to Jason for the introduction.
Yeah, welcome everyone, and welcome John. Appreciate just hearing a little bit about you already, but definitely want to add to that with this very nice bio. Mr. John Lindland has 40 years of international experience in automotive safety, critical design, and manufacturing. Mr. Lindland, apologize if I mispronounced your last name, holds a master's degree in manufacturing systems engineering and industrial engineering, quality, and statistics, as well as a bachelor's degree in electrical engineering. He began his career with Ford Motor Company and later served as director of quality for an automotive supplier before spending over 2 decades as an international consultant. He has contributed to major autonomous system programs, including Fiat Chrysler's Functional Safety Steering Committee, Raytheon's Unmanned Air Systems Program, and TuSimple's SAE Level 4 Autonomous Trucking Initiative as Director of Quality and Functional Safety. He retired this January 2026 and now lives abroad, as we heard earlier. So again, welcome, John. Appreciate it, and the floor is all yours.
Thanks, Jason. Let's see. Let me try to remember how to put my slides on top. Let's see. Jason, can you help me remember how to put slides on top? Presentation view. Share my. Share screen. Share screen. There we go.
Got it. Yeah.
Share screen. Yeah.
Okay.
So you might have multiple screens. Oh, there we go. Yep, we can see it now.
Okay. So here we go. To everybody, I apologize for running off at the mouth. I feel embarrassed, and forgive me. I like Bob a lot. I've known him for quite a few years, and I like sharing, and I talk too much at times, especially when it's unguarded, and should not have been unguarded. So we're going to talk about some concepts of functional safety. I'm going to cover the reality of functional safety. I was going to talk a little bit about the standards and things like that, but what I'm really going to do is going to talk about the challenge. By the time we're done, you should have a clear understanding of the difference between proactive and reactive quality safety, functional design, and you should have also a very, very clear understanding of the challenges. There is a way to solve and create extraordinarily safe vehicle designs. The current practices are not going to get there, and I'll explain why. When is autonomy free from unreasonable risk? When it is safer than the average human driver? When autonomy has solved all the rational throttle, steering, and braking challenges. Those are the three hazard functions. A hazard function is that which can directly cause harm. Safety critical functions are the sequential and interrelated functions that create the hazard functions. In the United States, light vehicles drive roughly 3 trillion miles per year, all road conditions and causes. There are roughly 8 to 12 fatalities per every 1 billion miles. I use 10 fatalities every 100 million miles as one fatality every 100 million miles as a simple argument. All designs have limitations. It's important to clarify the boundaries not solved by autonomy. So when you make a safety goal and you say, in 1 billion miles, the human beings cause 3 fatalities in this category, you're going to say then, I'm going to, my safety goal in this category is to produce 2 fatalities, not 3, or 1 fatalities, not 3. It's more specific than that. That's just a very, very simple example. Autonomous vehicle controls. The 2 controls over the AV's kinetic energy. 1/2 mass times velocity squared is the kinetic energy. It's the hazard energy. In a crash, that is the energy that can get transferred into a vehicle, a pedal cyclist, or a bike. It's the one that can cause damage and death. You have lateral steering, left, right. You have longitudinal, speed up, slow down. Level 1, you control one of the 2 groups. Level 2, you control both groups. So you might do lane centering with dynamic cruise control. All kinds of problems with this level of control, by the way. Most of them are designed with closed loop systems, and they can't tell if the forward vehicle is actually in their lane. On a curve in the freeway, they often pick up the wrong target. Many of you have these, and you've seen that. That's why it happens. They go off path on the road because it picks up wrong lines and thinks it's the road lines. Manage a safe planned path within an ODD level 3. The driver identifies and reacts to emergencies. Now, Tesla is trying to say we're level 2 plus supervised. And just as a quick statement, they are 4 times more deadly than a human driver by himself. And they're in court all of the time. They've got a class action lawsuit. They just lost one lawsuit for, I think it was $240 million, where they drove down a road. The road ended into a left-right T. It went through the end of the road sign, ran into a young couple stargazing, and killed them both. That's a gross failure of the obvious. Restricted level 4 is a point-to-point, restricted to specific paths. Point-to-point driving with the capability of all pre-crash scenario. Level 5, full autonomous driving in all conditions over a broad OED. OED is an operational design domain. What are you going to solve inside this confined scope of design? What are the challenges within that? Call it a geo-fenced area. Geo-fenced by the map and GPS. This is the SAE graph. The previous page explains this in more simple terms. This is a point of conversation. Nobody designs to a level 2. Nobody designs to a level 3. Nobody designs to a purely designed level 4. If you're going to create a bus that goes around a university in a loop, that's a perfect level 4. Transition of road segments. When you change from one type of a road to another, all of the challenges change. All of the spatial and time sequence things you have to recognize. They're spatial, where are things? Time sequence, what are they doing? All of those change. How the same category of crash presents itself changes. You have to recognize different things, and they're drastically different patterns, recognitions to react. So you have rural and urban, and I'm not going to cover this other than to say when you travel between these, the challenges change significantly, and how the same categories present themselves change. Road grade access. Road grade access versus mobility. Residential has direct access to a home. You then leave residential and you go into roads that don't have any in the city, don't have any houses entering the road unless you're in a rural city. But the important thing to look at on this page, in here, these areas here where they're just nice and smooth, those all represent laminar flow. Laminar flow is inherently free from risk. When you start getting over into exchanges, lane changes to exit in a different area, going on a freeway and you need to go to the other side of the freeway within 400 meters to exit on the other side. That's a highly dangerous situation. Scenarios turn into pre-crash scenarios in a fraction of a second. Then you get into the collectors, and in the middle of the collectors, nobody's exiting. Everybody's a pass through. Here, everybody's a pass through, inherently safe. Same thing at the end. The city of Phoenix has 4,850 miles of roads. Can you drive the same 1,000 miles of road day after day after day after day, or week after week after week after week, and only get the same type of surprises, or will you keep getting new surprises? The answer, it's asking a rhetorical question. You can't. Every one of these areas that are colors represent potential homogeneous road challenges. The beautiful thing about Phoenix is it has areas of 5 and 10 and 20 blocks along that all exhibit the same challenges. So if you solve all of the challenges of one block, you solve all of the challenges of 10 blocks. And that's the idea of a representative road segments. In here, you could probably break Phoenix down into about 150 to 200 representative road segments. And then, do it by block or groups of blocks. And they all have exactly the same challenges, same number of lanes, same control devices, same cars, vehicles, pedestrians, pedal cyclists, same types of schools. And now you take the most challenging few that have all of the challenges, you solve those few, you've solved them all. Model the few, solve the few, the rest are you have perfect solutions for the rest. Representative road segments have the same road configuration and controls: vehicles, pedestrians, and pedal cyclists. Object recognition, spatial sequence pattern recognition, driving environment. The driving environment is macro. Where are objects and what are they doing? Micro is what is the object? What on the object has predictive patterns? So spatial is the person. A person's walking down the side where walking. Your vehicle's driving past them. They're not going to jump out in front of you. You don't have to study them in detail. You only have to study the surrounding objects that show an indication that they're going to change their mind and they're going to enter your planned path. Now, you see that person look back over their shoulder. That's an early warning sign. So the attribute on the person is their head and their shoulders. Now you see them about 3 seconds later do it again. Did they hear a noise or are they looking at something? You can actually place probabilities on everything. They stop, they look over their shoulder, they stop, they turn. But if their eyes, if you have a camera looking at their eyes and their eyes go perfectly round, they're looking at the driver. 9 out of 10 times they're going to step out in front of that car. You can take this down to a science of probability and say there's a 40% chance they're thinking about crossing the road in front of me. You can take that down to they've changed their path, they've walked out to the edge of the road. Are they going to cross or are they looking for somebody? Those are two different choices. Road classifications and mixtures of road grade access. They have representative road segments have the same choices of the entry, exit, and pass-through flow. The same dynamic task challenges: laws, ordinances, right-of-way, parking rules, emergent and sudden emergent surprises, crosswalks, and so on. Here's a surprising one for you. Google started developing their technology in 2009. It's 2026, 17 years later. They just hit a child after illegally passing a bus. They still haven't solved the obviouses. I'll cover that later. A few segments that are most complex and representative of all challenges in all other road segments. Solve the few, solve the rest. Very tractable. You could study San Francisco in 6 months to 8 months. You can collapse the whole city down into representative road segments, at the end of which you'll have all of the sensor requirements, distance, speed requirements. You'd be able to select your sensors, spec everything out. The most critical aspect is sensor at distance and knowing what you have to capture, and that's all signal to noise. If it's a camera, you have to have enough pixels so you can resolve a statistically stable signal, object digital signal, before you need to make a decision. You need to see it, you know that it's real, understand it, put it into the context of the road and what's going to happen. 90% plus of everything around you, you only care what is it, where is it. It's not going to intrude. Don't overanalyze it. Leave the computer processing space open for the things that are immediately surrounding you, your level 1 constraints, your first order constraints, and your second order constraints. Those are where your surprises and intrusions are going to come from. Third order relationships are just like designed experiments. George Box, one of my advisors and friends, and Stu Hunter, his student, a very good friend, said third order relationships don't exist. Well, they do. And some of them are in chemistry are highly prevalent. In autonomous driving, they're very real. See, you have so many exposures that very small probability of a third order relationship makes it real. But you have to have a reason to study it, or you don't have any bandwidth left in your processing. Reactive and proactive critical design process. Reactive has no end game. Proactive has a defined end game. Reactive safety critical design. An AV is created with a basic object and event detection and response capability. It doesn't understand all the road geometries and control devices in its ODD. It doesn't even know its own map. It does not understand the laws, rights of way, and constraints and constrained space rules. It's not capable of planning all safe paths in the ODD. I pick you up here. I'm going to take you 15 miles away. I know all of the risks of the road between here and there, and I know which of the lanes I need to be in way before I get there. It doesn't figure out the path on the way. It pre-plans it, and it only changes from that if it has a reason. You have priorities for your planned path. Number one is safe. Safe is above legal. Number two is legal. Number three is to get there on time. And number four, and so on. So you end up, there are actually 5 different prioritizations that make sense. I've documented those and as part of a book I haven't published yet. I keep playing with it and I keep threatening to publish it, but it's about 650 pages and it's kind of like chess by yourself. It's fun to think of and fun to keep massaging. It is not capable of recognizing all objects and pedestrians and pedal cyclists. It cannot understand the spatial and time sequence relationships of HAZOBs in the driving environment. All AV manufacturing companies follow the make, test, fix design process, also called find and fix. They believe that the AI will eventually master all risks and complexities of driving. There's a really interesting video, you might want to find it. It's where Waymo confuses themselves on the same road. One's coming in one direction, the other's coming the other direction. They stop. There's plenty of room for them to both path. They don't even know their own size constraints and distance to the surrounding objects, and that it's obviously safe to pass each other. AI cannot solve that. It needs comparative references. How much room do I have? How much variation do I have at speed? How much variation do I have left, right? How closely do I arrive at location on time, at the planned time? Or stop in the right location at the planned time? They have safety remote drivers identify and react to to events caused by AV failure. Every failure is a potential single and or multiple vehicle crash. At 40 minutes, the safety driver's performance degrades. You have high fatigue that occurs between 105 and 125 minutes. The reaction time slips at 125 minutes. It's absent in 1 month. So the better you get, the more certain the more certain you are that the driver will not react. So at that moment in time, if there are 100 chances for a crash, they're going to react to a few of them, but not many. They're pretty much absent. Find and fix statistics. Causes are found in groups and can be modeled by the Poisson distribution. 20% of causes should be found early and 80% of failures avoided. Possible in a homogeneous representative road segment. I've already covered that idea. However, if you solve it in a homogeneous representative road segment, it will not work across all road segments because the spatial and time sequence relationships, the entrance, exit, and flow through all change. You can only solve these patterns within a homogeneous representative road group. That's why you have to break them down and solve them individually. And then you combine them, and then you can see the similarities. All have failed to solve the simple and obvious. 17 years, Waymo hit a child. And they claim to be 90% safer than a human being, but they drive the simplest roads in a controlled space, and they're not comparing their statistics against humans driving the same roads. They're gaming the numbers. None have ever solved this, Waymo. Time between causes follows the exponential distribution, and this is the death of this approach, find and fix. At first, causes are found every day, and each greatly reduces the number of interventions. Grand stories to investors. I've seen this. I've been part of it. I expressed my concerns. But a company was rushing to an IPO, and that company later did a crash and burn spectacularly. By the end of the first year, causes become specific to effects and can only be applied to a representative road segment, not ODD solutions. Exponential find and fix, beginning with 2,910 interventions. In a mile, humans have to respond 2.91 times per mile to mild through surprises to avoid crashes. And that could be slowing down, speeding up, changing lanes, waiting a minute until it clears and things like that. But these decisions, this is not the mindless decisions where you're driving and you can't remember the last mile. You notice something and you have to change. When you drive autonomously and you're not really recognizing anything, you are in laminar flow. It's inherently safe. Every find and fix places a life at risk. The exposure is 100%. So this right in here is the growth curve, beginning with in 1,000 miles, you have to find and master these numbers of things. Waymo is not at 291 in 10,000 miles. Nobody's even close. Now, let's say that Waymo is here, and they're at 1,000. Well, 1,000 then becomes up here, and the same exponential growth curve comes here. This is the time. These are the number that are found and the time between finding. The groups come in the Poisson distribution. You find them. Now you're going longer and longer. A human being at 10,000 is still has these 291 are surprises. They're significant events. They're the oh my God, honey, we almost died. And up in here, they're still struggling with the basics, so they're nowhere near here. This is the gulf that an AV drive, find, and fix cannot cross. None of them will make it through the end. Waymo, the way they're going, will never make it across. They'll never make it to this number because they're driving and finding and fixes. And after 17 years, they still don't know how to manage passing a bus. And they ask contextual advice from an individual sitting in the Philippines who gave them contextual advice and then decided that it's safe to drive past the bus. I live in the Philippines. There are no driving rules like that. They have speed limit signs that nobody pays attention to. I love it here. I do. But there's no chance in the world that they could be contextually competent of advising AI in the United States. It's just not. It's just whoever made that decision needs to have a conversation about what it takes to produce competency, the ability to make the right decision and do the right amount of work within a given amount of time, and it's based upon education, training, and experience. My hiccups, I got them just before I started. I'm embarrassed, but I'm going to keep going. A human being fails 10 times every 343,643 miles. And this is where you end up with crashes. Except for 9 out of 10 of these don't happen. 1 out of 10 turn into a crash. So you end up here with this growth, find and fix across all road segments within the ODD. Waymo is doing the simplest ones now. They're going to the more complex ones later, and they're applying what they've learned on the simple ones to the more advanced ones. The only problem is spatial time sequence relationships are different. The hazardous objects risks present themselves differently, vehicles, pedestrians, pedal cyclists. The entrance, flow through, and exit requirements change. And it sounds like a good idea, but there's no end game. So if you have 291 failures per 10,000 miles, the safety driver is not going to react. The AV is driving blind. That means intervention means the AV doesn't recognize there's a reason it needs to do something differently. There's no response. Object and event detection and response. There's no response because everything else is missed. It does not avoid 9 out of 10 crashes. So when you get to that 10 that a human being sees and they react, that means the AV is 10 times worse than the human being because they're not trying to avoid. The graph, the exponential growth curve I just showed you, has that flaw that AVs do not react. The probability of a single vehicle crashes is 100%. They're going to just drive into whatever it is, drive off the road to wherever it is because they don't think they're doing anything wrong. And they're not afraid of death. Assuming the HAZOB does not step out of the way, you have 29,100,000 crashes. You have 20,661,000 property damages. You have 8,439,000 injuries. You have 84,000 critical and or fatal injuries. The AV does not mitigate by avoiding the crash. There's no swerving, no speed reduction. The statistics above is a breakdown, and I'll show you here in a minute, of human-related percentages. But since the AV doesn't respond, it's going to be worse. Human drivers, they crash once every 343,643 miles. That's using a set of statistics from the National Highway Transportation Safety Administration. If you look at those numbers from a different year than what I did, you're going to come up with different numbers, but the story and your conclusions will remain the same. All models are wrong. Some are useful. That's what George Box taught me. In other words, they can make an argument, but they don't explain the world. 90% of significant surprises are avoided by the human being. The 10 that are not produce crashes. 71% of crashes are property damage. 29% are produce injuries. And I've looked at this over and over and over. And MAIS is maximum abbreviated injury scale. It takes you into 6 categories. CABCO used to be the old one that was done many, many years ago. I find this is a good example for this is a great way to categorize ISO 26262 road vehicle functional safety severities 1, 2, and 3. So if you have a crash, 71% of the crashes are property damage. A crash doesn't mean you're going to kill somebody. It means there's a probability. This can take that 29% of the crashes and rationalize it so you can make objective decisions. Proactive designs define the autonomy, reduction of harm, safety goals, and loss. Model all pre-crash scenario right-of-way, emergent, and sudden emergence on all representative road segments. Assign functional safety requirements to produce capable OEDR. So as you identify these relationships, and there's a way where you can actually numerically relate the probable risk of throttle, acceleration, deceleration, steering, and braking to each of these categories. And you can do this numerically with correlation coefficients. It's actually quite simple. In Autonomous Vehicle International, I have 3 articles on HARA. I think it's the 3 of 3 covers that topic in detail. So if you're an expert and you want to take a deeper look at it, it'll walk you right through it. And if you want a copy of the HARA reports that I use, it's what I start working with teams with, and you're free to use it. I'm giving to society. I'm retired. I'm not looking for clients. Optimize all functions or sequence and interrelations. Validate functions of all levels to these requirements. Design, validate fault detection. Design, validate safety mechanisms. By the way, fault detection. When you're doing the system analysis, you identify a functional block diagram that upon the functional block diagram has 100% of system level functions. Each one of those you can predefine which of 7 ways they can fail. They can be omitted. They can be this function can be too large, too small. It can be unstable. It can be biased. It can have linearity problems and such like that. It can occur too late. It can occur too soon. Each one of those has design parameters that, if they're optimized, will completely avoid the failure mode, functional failure mode, the function fault state, and I'll talk about that all in a little bit. What I just said was this: by the time you're done analyzing using the 7FM techniques, and that's called functional block diagram, becomes a fault state map. You have a 100% map to clarify and plan fault injection, and you can actually test 100% of fault detections and safety mechanisms, and under all conditions, you can actually validate the fault tolerance time interval. Do you notice it soon enough that you can correct it, divert into a safety mechanism, and regain full or safe operational efficiency? Validate variation in safe passing and stopping capabilities. And design and validate all pre-planned escape paths. Proactive safety, eliminate the top causes of failure. 7FM premise, they are all definable as the design is created. That is absolutely factual, and I'll show you why. The mean time between failure multiplier and reliability growth. Growth is achieved by removing top causes. Prevent causes from being included in the design increases reliability. Ralph Nader, I think it was 1965, wrote a book called Unsafe at Any Speed. That became the basis of massive class action lawsuits because he claimed and proved that unsafe results are because causes are included in the automotive design. When you see, for example, the most horrendous example of unsafe practices was, in my opinion, called Tesla. When you see the crashes they're involved with and you say, my God, that was so obvious. Guess what? The causes were included, and it was the Tesla was driving blind. A young female engineer from Tesla got drunk, said, drive me home, put it into autonomous mode, and never woke up. She died, and she was killed. Mean time between failure is inversely proportional to the failure rate. So your multiplier becomes this. Going from 1,000 to 1 million miles between interventions. Removing the top 20% of causes avoids 80% of the effects. If you do that, and you're doing this in a proactive way, so you're doing this to solve all of the pre-crash scenario, spatial time sequence patterns of all of the representative samples, this is what you're going to get. You're instantly going to go from 1,000 to 5,000 miles. You're not going to solve all of the problems in between because you already solved them. If you remove the top 50% of the causes, you're going to avoid 92 to 94% of the effects. It's 14 times. You're instantly going to jump to 14,000 miles. Remove the top 80% causes, avoids 98 to 99% of the effects. You're immediately going to jump to 100,000 miles. Now, in here, you solved all of the rational pattern recognitions. You can do this with a competent team. You don't need a team of absolute experts. Competent teams is what produced the most reliable vehicle in its class and the best vehicle in its class 5 years running, Chrysler Pacifica. We took a year off production. How much money did that save? And you're going to get these types of results. This is very real. 2 years, start to finish with autonomous vehicle, you can reach this. You can take Waymo in 2 years, turn them into a fully capable driving system, but you can't do it the way that they're doing it. Remove the top 5% of the causes, avoids 99% of the effects. This is actually called infinite reliability because the 5% of the causes you don't remove occur so far in between on the exponential graph. You're way, way off the limit. So you're not at 1 million miles. You're actually probably at 1 billion miles. A rock has to fall on the car. Something truly unusual has to happen. I mean, but normal driving conditions, you're not going to get, oh my God, they missed the obvious. Prioritize theoretical functions, perform resource planning, prioritize correlation of all system functions to hazard functions and failure modes. These are the inputs. The most critical ones are sensors. You also have EE boards. You also have power and things like that. These are at the system level, these would be the system functional blocks, the assemblies of code that create the functions, because autonomy is driven by software functions. Software functions ride on hardware-software interface. Hardware-software interface are supported by the board design, the conduits, the runs, the traces, and the power and the grounds and things like that. So in here, these are going to be all of the system level functions, and they're going to be the system major system level individual hierarchy. Down here are the noises that will degrade the system over time. In abbreviated terms, the prioritization for electronics is going to be vibration first, most important degradation factor, temperature second, chemicals, residuals from manufacturing, debris, and radiated energy, which is why in automotive, they do all kinds of EMF studies so that when you're going past an airport, it doesn't fry your computer. These are the most important. This is where you put your people. You put your people on these right in here. These are the red ones I have here represent the top 50% of causal factors. You're not guessing. You know for a fact the mathematical relationship. These are transfer correlation coefficients. This is 7FM quantum quality. Very easy to do, very powerful. And then you can do within the blocks. These are the intended outputs. These are the system level functions. Which ones have the highest risk for degradation? And how do they relate to the steering, throttle, and braking, acceleration, deceleration, braking, hold position, things like that. These will tell you the highest exposure and where you need to put your design, and you relate these over here. So you relate the middle one here over here by focusing on the top relationships within each group. But you're not guessing. You're highly focused. You're not trying to fix everything. Trying to fix everything is how you go broke. Optimize each function's designs. So you have a function, and the function at the concept phase is identified functional safety requirements of the system function, the system element, and the system function that will achieve the safety goals. So you assign it to dynamic vehicle controls. You assign it to vehicle controls. You identify it to motion constraints. Recognize these 5,000 different types of unique motion constraints that will limit me. I have a place that's open. A car is speeding up. It won't be open when I move in there. A car is going to fill the place. There's all kinds of things. I need to see this at this distance. I need to be able to see at 50 meters that a human eye is round and they're looking at the central camera. They're going to step in front of the car. I need to see their hands, their motions, their movements. And you need to have a camera that sees the surface. You need, it picks out patterns, and it needs to see the LiDAR with its point cloud, and it picks out objects based upon relative distances and differences in speeds. 1 centimeter per second between objects, it can detect the difference of speed. Is it a different object, or is it a hand moving? Is it so what is it? So the camera sees turn signals, brakes, and things like that. You have an imaging radar. An imaging radar sees the mass. So the camera and the LiDAR both see an object. They don't really fully recognize that the imaging radar doesn't see it at all. It has no mass. You can drive right through it. You need to sort out all of these types of relationships. It takes all three to get close to the human context that a 5-year-old child has. Oh, you can run right through that. That's an empty box. I can tell by the way it's blowing in the wind. Following function requirement, and here's another one. You got 2 kids riding in the back of a pickup truck. No, that's not a kid standing in the middle of the road in front of you. You don't need to slam on the brakes. So the attribute of the pickup truck contains human beings in its space. The big object is the pickup truck. Part of the object is everything attached to it and around it. You need to recognize it in context, so you don't make this. Oh my God! I couldn't even figure out that it's somebody in the back of the truck. It's a dog. You better slam on the brakes. Now, anyway, following function requirements. This verb has to satisfy the following function requirements. Latency. If you try to analyze too many things, you're going to arrive at a location later than you planned. You're going to hit something. You can't study too many things in depth, but you have to have a system that is powerful enough and can crunch enough information so that you can account for a delay and plan over the delay. That means move your model up and estimate where you really are, so you're making decisions at time. You have measurement system capabilities, sensors, and ground truth translation. That's a big topic. Meet fault time tolerance requirement intervals. And so these are all of the things you have. And over here are all the things that will create this function to satisfy these. If one of these over on the left-hand side is faulty, not all of these will be affected, but which one will be affected? This will be perfect when these are perfect. Design parameters are conditions before the function cycles. If you get rid of everything that's important here, if you get rid of 80% of all of the problems, a competent team will identify 100% of these things. An expert team will optimize 100% of these things. That's the difference between a competent team and an expert team. An expert team, this function will degrade, but it's going to degrade at a much later time, many more miles down the road before it starts to degrade, before these start to become problematic. Missing functions, optimize the linkage between functions. You have missing functions, missing functional following requirements, missing function parameters, design parameters not optimized. The form I showed you in the previous page, this is where we do it in 7FM. I freely share my 7FM Excel workbook. I want to accelerate. I've had a very happy, successful life. I'm giving back. Every input-output requirement must be linked, traced, and rationalized. Requirements are Legos. They are interlocked. Functions are dominoes. They fall into each other. AV safety failures, crashes, single vehicle crashes, failure to follow the planned path. I've already covered everything on this page, and I've already covered everything on this page too. This is the AV. This is what first order relationships mean. This is what second order relationships mean. Third order relationships are things that will cause the second order to change. Then it will cause a ripple response, and the second order will also change, but not as much. And the third order has to be very significant in order to affect the AV. There need to be pre-approved escape paths for all sudden emergent intrusions into a planned path. You have to have them pre-planned. You have to know that they're statistically safe. And if all of the constraints are filled, you know which of the constraints which of the occupied first orders constraints exist, which one is the safest one to intrude. Then you become the third order to a second order to a third order relationship to another vehicle. They will dodge. 9 times out of 10, they will give you room. First order choices, when they are open over and over, you have a planned path. You slow or stop if you have a capability of stopping that's greater than a CPK of 1. You slow and or swerve into an open. You slow and or swerve into an open first order spot. Behind you, right, behind you, left. You swerve left or right. You accelerate left, right, straight. It's going to hit you, but you can accelerate. It won't hit you. When all first order spaces are filled, intrude into the first order space with the highest capability in the preferred order. Vehicle, pedestrian, pedal cyclist. Crazy as it is, most pedal cyclists live when they get hit by a car. Their knees and their lower legs most of the time recover, but they don't die. I didn't say hit them. 9 out of 10 humans get hit on the front of the vehicle. The second biggest category is when a vehicle is taking a right-hand turn. That's a fraction of the 10%. Final validation, stable design, no human intervention. To compare an AV to a human, and think about Waymo. You can't compare this until the design is frozen, it's stable, and they say, I'm safer than a human being. I'm going to drive the miles, and there's going to be no intervention. We don't need to ask context advisors about what to do. The human across all roads in the United States, every 100 million miles, you expect a fatality. An AV is simpler when the slope is smaller than 1. Whatever your ODD is, this line is going to equal a slope of 1. Any slope lower than 1 that's outside of a binomial confidence interval, if you have any statisticians in the group, you would actually be able to do a binomial confidence interval on both sides, so you can say it is statistically less safe, it is statistically safer. Pre-crash scenario are defined by the National Transportation Safety Administration. This is important because all police reports define spatial and time sequence relationships. But most of those, you can see, they're obvious to a human mind when they're analyzing the representative road segments. 80% have 6 scenario. 15% have 11 scenario. 5% are all others. What if I suggested we're going to get rid of 50% of the 80% and 25% of the 15%, and that will cause a reduction down here, but we're really not going to spend time on these. So, but we will guarantee that the statistics won't be higher. And what if that was the rational design focus, and somebody said, well, what if somebody gets drunk and lays down on the road and you're going to hit them? I say, well, they made a bad choice. You can't solve the world's problems, or it will freeze the design team's minds. I didn't say don't think about human life. I say be rational in your choices. Be efficient in your choices. Do not let some silly person who's trying to imitate the smartest person in the room, and they're not, present problems that the design can't solve right now and then start acting on that specific, unrelated to any type of a prioritized risk challenge. That's just silly. Pre-crash scenario across all road segments have hundreds of spatial and time sequence patterns to recognize for each pre-crash scenario. This is too complex to figure it out as you go. Waymo is trying to figure it out as it goes. They stop and they figure it out. I want to say something about Waymo because I've been beating on them. Early on, I wrote a rebuttal about Waymo's first claims about being safer than a human. I expressed why that wasn't true, and that response went viral. Oh my God, it was amazing. I got contacted by the head of safety for Waymo, and we had a good conversation. And I shared some ideas about them. They introduce their vehicle in a very rational and safe order. Out of all of the companies, Waymo clearly has the best safety culture of any of the AV companies right now. By far, they are ethical. They are doing everything they can to protect the public. They're making silly mistakes, and I don't think they're going to get to the finish line. You know, you can't find and fix your way to success in a complex safety critical, a complex system safety critical design. You just can't do it. Representative road segments produce a tractable number of spatial and time sequence patterns. So each one of these occurred differently on each one of the representative road segments, which is why you need different camera requirements, different speed distance requirements for detecting the objects and their attributes and so on. And you have different variations. MAP holds all road segment entrance requirements. You enter a road segment, it tells you here are the flow characteristics. There's a probability that 10% of the vehicles are going to exit into the shopping. There's a 15% chance that all of the vehicles at the next road are going to go to the left and exit on the left. You know the probability, the congestion. You know the optimal road lane position for your choice. You're driving through, you're in the middle. You're not in the left. Pre-crash scenario. So these are all of these, and I'm not going to cover them. You can look at it as you want. I've already expressed the basic ideas of all of these. I just wanted to have them all clearly called out. This is the planned path. It is a ground truth planned path that has you in the optimal position in the lane. If your vehicle is long and you're going around the corner, your optimal position is away from the center of the corner. So you have more room on the corner side, the inside, and you're crowding the outside, especially if you're in a truck. This is a fourth order polynomial. The first derivative is your steering angle. Your second derivative is the velocity of your changing in steering. Your third derivative is the acceleration of your steering angle. The acceleration of the steering angle against your speed will relate you to your speed cornering curve, which has limitations. You can predict the fastest you can go around any corner and avoid a loss of control. You can avoid instability because you also know the road shape and you're predicting that out into the future. You can plan your stability prediction, even for a Class 8 vehicle, for 1,000 miles because you're predicting it for the next 1,000 meters. You have a road surface in the map every 1 meters. You've got a fourth order polynomial, so it shows you all undulations and everything else. You know how the vehicle responds. You've already mapped out all of the instability metrics, which are roll, tip in, and yaw. Anyway, I went way too far, but there's so much you can do with that. You can predict your complete safe path and speeds and avoid all instabilities, even on an icy road. Statistical capability considers the variation of two different distributions, HABOP width path with variation, AV width path with variation. The risk of unreasonable harm has been avoided when the hazard distance is twice the variation distance. So this is the variation distance. That's the hazardous. These are 3 standard deviations. Even in a non-normal distribution, it's very easy to model the variation, and the skewed side distance is the distance that you need from the mode, not the mean. The skewed side distance is where you need your capability. Twice that distance gives you CPK of 2. I'm the one that in Ford Motor Company in the early 1990s, late 1980s, created the non-normal CPK analysis that the world's using. I haven't been referenced since the mid 1990s. Increased speed and noise risks, planned path variation, noise, wind, uneven road friction, road crest depressions. Basically, the faster you go, the bigger your variation. This is just the road surface. This is the wind. Potholes. Instability of the vehicle that grows. The AV can measure this dynamically and update it as you drive. You'll always miss the things that you should miss. So when you have 2 objects and you have a CPK of 2, you have 0 overlap. There's 0 probability that you're going to cross. If somebody's saying, well, a normal distribution extends to infinity plus or minus, I would like to draw your attention to the Johnson equations and a couple of other equations that go between A and B. And between A and B, you have 100% of the variation. Walter Schuhart said, all the variation resides within plus and minus 3 standard deviations. That's factually true. It doesn't extend. You can't say it's 6 standard deviations. There's 2 chances in a billion you're going to hit something. You have 0 chance. You're never going to hit them. All models are false. Some are useful. Understanding and not getting lost in theory is quite important. If you pass somebody in an emergency in a CPK of 1, you're intruding into another vehicle space. The probability you're going to hit them is going to be about 1% if they don't swerve. That's what this 0.089 means. That's the combined variation interference between body to body at that point. If your CPK is 0, you're going to transfer 100% of the kinetic energy into whatever you hit. If you're at CPK of 1, you're going to take the dust off the surface. You're going to rip the shirt. You're going to rip the skin. You might gash somebody across the tummy, but you're not going to be breaking bones. And these are the different relationships of probabilities for capabilities. Validation. You master speed, throttle, and braking, and you model them so you know the variation of all of them at all speeds. Basic functions, combined functions, arbitrating functions. When you start combining functions, mastery of maneuvers. Mastering of maneuvers. Following a planned path is this. Mastery of following the planned path through traffic. You know all of the driving regulations, the rules, including confined spaces, how to handle schools and things like that. And you're mastering all of these SAE through level 3. You're not getting involved in pre-crash scenario. Level 4, you're mastering all of the only that portion within your point to point, and you only have these complex scenarios for pre-crash scenario. You don't have them all. You only have those offered to your planned path. When you get into to 5, you're moving over to the right. Mastery of complex scenarios are when situations turn into pre-crash scenarios. The ability to see it and predict it and avoid it. And this is where you have to have a pre-authorized, pre-planned escape path calculated at every instant. So when a child jumps out from behind a car, you know you're slamming on the brakes. You're going to swerve left because the child is coming from your left. You're going to swerve left because by the time you get there, the child will pass where you would have gone had you gone straight. You're not going to hit the brakes. You're going to hit the brakes and swerve. In NASCAR, when there's a crash, the advice is to drive straight at the crash because by the time you get there, nothing's going to be there. It's the same idea. Then at the mastery of fault management is the top level. These are your fault detections, your safety mechanisms. These are also recognizing when the vehicle is breaking down, so you have to drive differently. And that is the end. And I think I hit my time, maybe went a little bit too long.
No, you did well, John.
Oh, thank you.
Minutes. Yeah. All right. I think at this point we could open it up to questions for John. If anybody's got any questions.
I'll let you mediate this, Jason. Or yeah.
This is Orion, but yeah, Orion or John or Bob or anybody. Anybody have questions?
Not a question, but a comment. I thought, John, you did an excellent job. A lot of material to cover, a lot of detail, and get into quite a bit of statistics and engineering. Definitely what we would consider a hard skills type presentation, but I thought you did a wonderful job really laying out the thought process and all the engineering work that has to go into building safety into vehicles, autonomous or not. There's a lot of failure mode effects and analysis, cause and effect to look at, and all the modeling, talking about getting down into first, third, to fourth order parametrics. So a
There's
lot.
an
You
interesting point
gave
on
us a
that.
lot to think about.
An autonomous system easily has over 100,000 safety critical functions, magnitudes larger than an entire vehicle. And
Yeah.
they're all very complex, and they can all be handled and approached and produce an incredibly safe design. Just at the systems level, you easily have 100 times more safety critical functions than in the entire vehicle by itself.
So how soon before long before we get to AI-driven chips in the vehicle microcomputers, be
Well,
able to
they
run
already
all
have
these equations?
they already have them.
Yeah.
Now the problem is they're trying to drive and let the AI figure it out
Hmm.
versus designing.
Right.
AI is driven by lesson plans.
Yeah.
Now, if on all of these representative road segments, all of the challenges can be uniquely driven and divided into representative road segment lesson plans, but there must be a comparative reference. If
Right.
the AI develops a new relationship, it is not authorized to activate it because it could be stupid. And also, it has to have constraints on what it can or cannot do. It has to know if it can fit in a space before it drives into a space.
Right.
And it can't figure that out on its own. There are all kinds of physical constraint relationships. And, unfortunately, I'm an old man, and I don't have enough time to get in there and fight like a young man like I used to. Used to be very aggressive, and I the path they're taking right now, they're just not going to do it. They've already got enough processing power, Bob.
Yeah.
They've already got enough speed.
That's
Hey,
good.
hey, good evening, John. My name is Scott. I had a question about customer trust because you can have a car that drives, you can have things that drive, but are you going to get in one and sit in the back seat and let this car drive you at 50 or 60 miles an hour down the freeway? Can you talk a little bit about, John, about some of your analysis and how that relates to customer trust? And if you think the population predominant of people will gravitate toward the technology?
Only when it becomes obvious, Scott.
Yeah.
I'll give you an example. I'm not going to talk about the company. I was offered a ride in an AV in an AV, and I took about a 50-mile ride in it. I counted 10 legal violations uh, against stated requirements. I mean, it saw objects, and on the screen, it mislabeled the objects. It wasn't what it was. A motorcycle was a pylon driving down the freeway at 80 miles an hour. A pylon. Yeah, how are you going to respond to a pylon?
Yeah.
If it's a pylon, you can just drive right through it.
Yeah.
It's I would never take another ride in that company's AV. They're no longer the same. I mean, but the trust is, you're not going to lend money to somebody you don't trust unless you're an idiot.
Yeah.
Constant good behavior creates trust.
Yeah.
I must admit I have taken a Waymo vehicle from my home to the airport, but I insisted that it only take the back roads. And that was an adventure in of itself. I can't It really scares me to think of the autonomous freight trucks that are soon to be on our roads. I mean, that's a massive amount of mass and high speed. Just endangering everyone else's lives. That's
Yeah.
just
As far as visibility, have you noticed that all of those have gone dark as far as claiming what they've done and where they are?
I noticed Waymo no longer goes down the freeway here in Phoenix, and that they no longer drop off at the airport either. If you want to take them to the airport, they drop everybody off and pick passengers up at the light rail station, a mile or so away. Yeah.
There are a couple of those companies that I have extreme objective valid concerns that they're placing the public at risk. And they've blatantly made false statements about their capabilities. I can prove it. But yeah,
we're trying to encourage shareholders.
One of the things I didn't mention, if an 80,000 pound truck hits a 2,000 pound vehicle, it instantly accelerates that vehicle to 2,400 miles an hour. Airbags won't help.
No.
Yep. So that's an interesting one. I really enjoyed. Thank you for inviting me, and I enjoyed sharing. I really did. I mean, to be able to share ideas to the next generation is such a gratifying experience, and you've honored me by asking me to be part of your group. Phoenix ASQ has an exceptionally good group, and I'm honored to have been asked, and I very, very much enjoyed presenting. So thank you.
Thank you very much, John.
Well, thanks for being here, John. Yeah, we had about looks like 58 folks online, so I'm sure you pleased us all. So thanks for being here.
Thank you, sir.
Yeah, yeah.
And we will be posting his slide deck to my ASQ once he provides us a copy of a PDF. So,
You'll have that by Monday. I'm
you.
also going to review include a few articles I think everybody will like.
All right. Sounds great.
All right. Thanks,
Great
guys.
presentation. Thank you very much.
Thank you. Thank you very much. Bye now.
Bye, John.
John. All right. Well, looks like John's hopped offline there. At this point, we can move into the if anybody has anything to share, or we can jump into any networking. If anybody wants to come off mute and introduce themselves, we can do that. If there's anybody new to the group, is anybody willing or brave enough to come and introduce themselves? We usually get no one.
Anyone on the call tonight for their first time participating in the Phoenix section program?
Yeah, I am Quality Bob. I'm Scott. I'm the first time. I'm a longtime ASQ member out of the Bay Area in California and San Jose. I moved here a few years ago. I had the pleasure of meeting Chuck at the ASQ Lean Six Sigma conference. Hey, Chuck, love your background. And I'm a retired Army major and an MBB. And I'm launching a consultancy here focused on what we do and helping get the strategy execution gap closed and deliver business value. So just pleased and happy to be part of the group.
Well, glad to have you. Thank you.
Yeah, it's awesome. Thanks, Scott.
Yeah.
Hey.
Hi, Paula.
Hi. I'm in Arizona and I've been here for like 5 years, but my background is in drug pharma in New York. And then I came to Arizona and I did med device. So I'm a certified medical device auditor. And just recently I got a position as a QC manager in a company that supplies clean room supplies, like cleaning supplies for the clean rooms.
Mm-hmm.
Okay.
Yeah.
Great.
Awesome. Well, welcome.
I know we have some topics coming up in our future programs on pharmaceuticals and medical and healthcare. So we try to find presentations and presenters across all the different industries that are within the Arizona and the Southwest region. So if you have any thoughts or ideas, we'd love to hear from you. Maybe you've heard of a great presentation, or you know of somebody who's done a good job in the past. We're always looking for new possibilities.
Or if you're a presenter yourself. Yeah,
That's right.
that's right. Yeah. How about anyone else interested? That's good. That's the best showing we've had so far since I've been doing this since January. So thank you, Scott and Paula. Yeah, that was awesome. All right. I guess we'll continue on with some section business and ASQ business. And think all we have coming up for ASQs is we've got the World Conference on Quality and Improvement in May. That'll be in Orlando, Florida. So you can go to the ASQ website and register there. And then for section business, we do have a few open positions still. I know we've had some folks interested in joining the team. So if you are new to this Phoenix or in general, I mean, we have folks from across the states that are part of our team here in Phoenix and have joined the section as part of our leadership team. We have a few open positions. So if you're interested in supporting the Phoenix section and you like the way we handle our chapter here, please reach out to myself or any of the leadership team. Sam Chang is our nominating chair, so his email address is down here at the bottom of the screen, and my email is here as well. But all of our emails are on the Phoenix leadership page, and you should be able to reach us there. So if you have any interest in any of the positions, whether you would like to assist or take lead on the newsletter editor, arrangements chair, scholarship chair, or chair-elect. I believe all of those positions. We do have some folks interested in a few of those positions. I don't know that we've solidified any of them yet, but if you have interest, reach out and we'd be happy to have those conversations with you. All right, and do a couple clicks here. So whenever we get those slides from John, we'll post them here in our library. So if you go to the Phoenix section page, just click on the library. It should be one of the first few things that pops up. We
And
always
when
have
we,
our Yep, go ahead.
I'll just make a comment as somebody
Yeah,
who's
go
trying
ahead.
to keep up with all this posting. I'm going to try to make a news blog saying, okay, we've got the slide deck now for the presentation tonight, and here's the link from the library. But you can also go directly to the library.
Excellent. Yeah, and you should get an email if you're signed up for notifications saying that they've been
Yes.
posted. I always get an email whenever you post blogs, so that's great. So yeah, if not, you'll see it here in the library, and then all of our events. If you registered through the events page here, you'll see it there. If not, I think I put out a link on social media for some folks to sign up. But if not, you can come here to the events page to sign up as well. All right. A few of the other things that we're doing across the Phoenix chapter, we have Pat Olstead. He's our education chair, and we're doing some learning resources. So going back here in our library as well, we've put out some 1-point lesson plans. What those are some short focused learning resources, focus on some practical quality concepts. So essentially what we're doing is we're providing reference materials so that you can go through and have a quick reference guide for different this volume we're focused on descriptive statistics and learning series, and the most recent volume is focused on these topics here: the mean, median, mode, our standard deviation, data distribution, and interpreting those statistical results. So about once every quarter, we're putting out a new 1-point lesson plan. So you can go into the library and find that OPL. And then again, just providing that purpose is to strengthen our practical statistical literacy, provide quick reference learning tools, and support both new and experienced professionals. And then last month during our program, we put out a poll trying to find out how we could better engage the members in the community. And we got some feedback, and based on that feedback, we found that we needed to focus on more in-person engagement opportunities. It sounds like everybody wanted to at least get at least one in-person one in-person engagement opportunity this year. So, and then also expanding our practical learning resources and creating more networking opportunities. It's really difficult for us to do online networking, as some of you guys have seen. So thanks those that did come off mute and introduce themselves. So it is somewhat difficult to do that networking online. So we are looking to do some in-person opportunities there. So we have some upcoming initiatives. We're planning on an in-person event. So we're reaching out to some potential host organizations. We did have three folks mention that we could potentially go out to their organizations and do a factory tour. There's also some local, I think Payne Host has a tour that we can do, and then three folks from the last program we've reached out and contacted as well. I believe there's a few of those folks on this call tonight. So please check your emails, and if you can respond and let us know if you're still available to be able to host one of those tours, or if you know somebody that can get us in contact to host a tour of one of your facilities or factories. And then if all else falls through, we always have the opportunity to meet up at the Santan Brewing Company here in the Valley and do an informal networking event. So the leadership team is starting to plan those events, so we can all meet up as a group here. And of course, we always have to have the goal for that, and that's to strengthen our quality community here, provide reaching out to you guys and listening to that feedback, and to continue to support this quality community that you guys support us, and then providing learning beyond this monthly program. And then, as always, we have not everybody is a Phoenix section member or just a member of ASQ in general, but there are benefits to becoming a member and a professional member of that. So the benefits of becoming a professional member within the global organization: there's discounts on the training programs, events and conferences, and additional certifications. There's access to online and published content, so getting into our MyASQ and getting some of this additional content, and then updates on professional news and issues for current best practices and innovative emerging trends. So you'll get some additional access. You'll get access to these slides that John has put out, right? And some of our OPLs and additional things like that. Right? All right. So just some wrap-up comments. Next month, we'll have a tandem here of speakers speaking on Don't Panic, Pivot, managing critical issues to preventing crisis. So should be a pretty good, let's see, some tough names there. But we have Senior Technical Leader in Quality and Reliability and co-founders of Curious LLC, focused on helping organizations achieve quality and reliability excellence through engineering and leadership mentoring. Previously served as principal engineer at Intel and has over 25 years of experience in the semiconductor industry, contributing to numerous publications, patents, and industry frameworks. Her work centers on structured problem solving, customer-focused quality systems, and data-driven decision makings. So it looks like we have some folks coming from the semiconductor industry, and they'll give us a nice presentation next week. And as always, Jason is the one that puts all this together for us. He goes out and he finds these speakers. So thank you, Jason, for putting all this together and reaching out and getting speakers for us. He's done it. Yeah, and Barba, you definitely coordinate the events and get everything online, and you help out there too. So without you guys, it's definitely makes the community stronger. So here's the tentative schedule for future presenters. So I just spoke about next month, and then we have some RCA and FMEA practices, and And again, this schedule is tentative. Not everybody's 100%, but we wanted to provide you some insight into what we have projected for the future. So if you wanted to block your calendar and check back moving forward. And then again, these slides for this presentation will be posted here in some time shortly, and Barbara will have that posted. So.
And the presentation is almost always on the second Thursday of the month.
That's right. All right. Thank you for that, Barbara. All right. And then here's all of our social media. Give you a second to take a quick look at that. Right. And that's just about it. Is there any comments or questions from anybody in the group? No?
No.
Bob, did I miss anything?
I don't think so. You've done a wonderful job as usual. Thank you. I think we covered everything and it gave a lot of additional information and a look at the future as far as who are our upcoming speakers and topics. So wonderful. And you covered also the 4 still vacant positions. They are, for the most part, all virtual positions. We currently have a couple of our member leaders who are from outside the state of Arizona because the roles and responsibilities are virtual. So as long as you're a member of the section, doesn't really matter where you are. You can participate and get additional RUs for serving on the leadership committee. So if you're interested, please follow up with Orion and or Sam. We'd love to have you.
Right. All right. Well, thank you all for joining. And if there's nothing more, we'll see you next time.
Have a great evening, everybody. Thank you.
Thank you, guys.